Hi everyone, let's continue working on applications involving right triangles. So in number 3, we have a tapered shaft with a diameter of 5 centimeters at its smaller end that is 15 centimeters long. So this is tapered shaft, means it starts off smaller, it's circular, and it gets gradually bigger as you go, wider as you go. So the circle is getting bigger. We're supposed to figure out the diameter of the large end. Okay, so let's see. If we start with a 5 centimeter diameter at the small end, and then this thing is gradually tapering out and getting just a little bit wider. 3 degrees is not very much. In fact, this already looks exaggerated. This whole thing is supposed to be 15 centimeters long. And we would like to figure out the diameter of the long end. Okay, so this one I know is tricky for people to get the picture of. Just even getting here can be a little tricky, but once we get here, figuring out where the 3 degrees goes can mess with people a little bit. So the taper being 3 degrees is saying that this angle right here is 3 degrees, which means we do have a nice little triangle hidden in here. And actually there's an identical one down at the bottom. That looks like it scrunches in, but it shouldn't. So looking at that triangle, if we want the diameter, we need to know this side length right here. So there's our right triangle. We do know that the base is 15 centimeters. So we're looking at knowing this bottom angle, the adjacent side, and we're interested in the opposite side. So this looks like a tangent. Tangent of 3 degrees is equal to x over 15, which means x is equal to 15 times the tangent of 3 degrees. So this was a calculator part. 15 tangent 3 degrees is about 0.786. All right, so that's going to be just this little piece, the top and bottom here are going to be about 0.786 centimeters. So if we'd like to know the full diameter, it's going to be the 5 centimeters in the middle plus 2 of those 0.786 centimeter pieces at the top and bottom. And we'll snag this answer that we just used to avoid any extra rounding, which means our diameter is about 6.57 centimeters. Okay, so again, really focus on paying attention to any vocab used here and trying to figure out how to just set up the pictures. That's generally the tricky part. Once you've got a triangle, it's not very hard to get these trig functions to solve for you. Let's look at number 4 as well. In number 4, we have a support cable running from the top of a vertical beam to a point 30 feet from the base of the beam, and it's due to be replaced. We know that the cable makes an angle of 64.5 degrees with the level ground, and we're supposed to figure out how long this cable is. Okay, so here's ground. Here's our vertical beam. And we know that the cable is connected 30 feet away from the base of the beam. And it then extends up. And this angle between the cable and ground level, so the angle that the cable makes with level ground is the angle between the cable and the ground, 64.5 degrees. And we're interested in this length, so the length of the actual cable. Okay, so we've got the bottom angle. Again, it's safe to assume vertical beam, level ground, that should be a right angle. we've got this bottom angle, so we know adjacent and we want to know hypotenuse. So I'm going to use a cosine. You could, of course, use a secant, but generally, given the choice, I'll always just stick with sine, cosine, tangent. And if I have to do a little rearranging to get a variable out of the bottom of a ratio, that's fine. That's easy enough to do. So cosine of 64.5 degrees is equal to 30 over L, which means L times the cosine of 64.5 degrees is 30, which means L is 30 divided by the cosine of 64.5 degrees. So you could make that 30 times secant of 64.5 degrees, but I want to plug this in my calculator, so that's actually going to make me work harder. I'm just going to stick with my cosine. 30 divided by cosine 64.5. Again, assuming you're in degree mode, this should give you a good answer. If you get a really wacky answer, that's the first thing I would check. Are you in radian or degree mode? And I'm getting approximately 69.68. Okay, so 64.5, that's definitely going to be a bigger vertical side than, say, 45-degree angle, which would make them both 30. So it seems not too crazy. And the units on that should be feet. So just shy of 70 feet long. All right, thanks for watching.